Hello everyone. So today we're going to be working a little bit with integration by parts. Not so much performing an integration by parts, but looking at an acronym here that can help us out with integration by parts. So often when you're doing integration by parts, you can face a dilemma into what you could pick for your U. And this is where this acronym comes in, which is called L.I.A.T.E. That's how we pronounce it. Some people say it's the L.I.A.T.E. For me, it's L.I.A.T.E. And yeah, I think of a cup of coffee. So that's why I have that image or video there, that GIF of that latte being made there. So anyways, let me go into what each of the things here represent, each of these letters. L stands for logs. I stands for, or logarithms, excuse me. I stands for inverse trig, or inverse trigonometric. A stands for algebraic. T stands for trigonometric. E stands for exponential. Okay, so now let's go ahead and apply this. So if we had x squared e to the 3x here, notice how you have an exponential function and you have an algebraic function. So we check the acronym L.I.A.T.E. An algebraic comes before an exponential. So my u here would be x squared. Let's do another example. I have a algebraic function and I have an inverse trig function. Because inverse trig comes before the algebraic, I'm going to let u be arc sine of x, or sine inverse, whichever you prefer. And over here, I have a exponential function and a trigonometric. And the trigonometric comes before the exponential here in L.I.A.T.E. So u is going to be sine. And yeah, your dv would have to be e to the 4x here. And yeah, that's what the dv over here would have to be x. So dv is basically whatever's remaining. And dv would have to equal e to the 3x here. Okay, so that's what you would pick for your u and your dv. Now, a couple of things that I want to say. This is not going to shorten your computations in any manner. You're still going to have to go through the motions of finding du and v here. So you have to still integrate, differentiate. It just tells you like the path of like least resistance, as you can say, like the easier way to go about doing this. You sometimes will have to integrate some stuff twice, by parts twice. Sometimes you have to do one of the little called wraparound integrals or boomerang, where you have to add one integral to the other side. That's still going to occur here, all those things. And this is not always going to work for everything. Let me just say that in terms of, like if I had an e to the 4x and arc sine of x dx, the L.I.A.T.E. here is not going to help you out with the integration by parts. It just won't. You can try it out, and just for sake of time, I'm not going to actually go through it, but you're not going to get a nice integral out of this that you compute. So essentially this works out pretty well for us when we're integrating things that eventually will work out. How do I know if they'll work out? It's just from experience. Sometimes we just got to practice with that. But it is a very good general rule to follow. Okay, so that's why I wanted to go over L.I.A.T.E. I always recommend it to people. Just follow that. And yeah, for the most part, you know, this will work out in your favor. Like you'll be able to integrate at the end pretty easily. But if it doesn't, maybe it's just the function that you're integrating is really hard. That could happen. So just take that into account. Thank you.